All right, and part 2, the last part. First, we're going to look at antibiotics. So fungi produce toxins that kill bacteria. This is a big hint here. They kill bacteria. Scientists use fungi to produce, so we need to know what kills bacteria. The 2 treatments that we saw are vaccines and we saw antibiotics. Antibiotics are the ones that are used to treat bacteria. Vaccines, starts with the V, are used to treat or prevent viruses. So scientists use fungi to produce antibiotics. They also produce, antibiotics. Moving on, number 12. Mrsa, or MRSA, is an example of a resistant bacteria. People who become infected with Mrsa usually do not recover because we do not have antibiotics that kill Mrsa. What should we do to avoid the creation of resistant bacteria? Let's see, D. Use antibiotics every day. Absolutely not. If you use antibiotics every day and you don't need them, you are just teaching the bacteria to develop resistance. So that will create more resistant bacteria. C. Use stronger disinfectants. Although this kills bacteria, it doesn't really prevent the creation of resistant bacteria. Like that, resistant bacteria usually don't become resistant to disinfectants because they are so strong. Create stronger antibiotics. So this is great if we have a bunch of resistant bacteria and we can create these stronger antibiotics to kill them. However, this does not prevent resistant bacteria from growing and becoming a thing. So this would only kill resistant bacteria, it would not prevent it. Only use antibiotics when needed. This is absolutely the correct answer. You are only supposed to use antibiotics when the doctor prescribes them to you, and you are supposed to use them for the whole length of that prescription to prevent resistant bacteria. Number 13, which is the most effective antibiotic? The bigger the zone, the more effective it is. That zone is called the zone of inhibition. The bigger the zone, the more effective because it means less bacteria are growing around here. So that one would be B. And last section for this review. When people are infected with COVID-19, a virus, they experience symptoms within 2 to 10 days. Based on this information, what is the viral life cycle of COVID-19? So we learned 2 viral cycles for viruses. We learned about lysogenic and we learned about lytic. Lysogenic is the longer word, so it is the longer life cycle. Lytic is the shorter word, so it is the short cycle. Because they're telling us that symptoms arrived within days, this is pretty short. So I need to find the short life cycle, and that is lytic. So I can get rid of all of the ones that have lysogenic in it, because this is the long cycle. So now I just have to find the one that correctly describes what a lytic cycle is. It's lytic because people feel sick. Okay, sure. It's lytic because people quickly feel symptoms. Absolutely. This hints at how short-term the lytic cycle is. So your answer is D. Number 15. What can be found inside most vaccines? Let me scooch this up so I can put the answers in here. Inside most vaccines, the most common vaccines, you are going to have an attenuated, which also means weak version of the virus. Attenuated or weak virus. So that is how your body can make a memory of the virus if it is ever exposed to it again. So the scientists put dead or weak pieces of the virus into the vaccine, introduce it into your body, and your body's like, whoa, what is this? All right, I'm going to make cells to protect me against this. And if you ever come across those cells in real life, your body will already know how to fight it. So, inside most vaccines, bacteria that eat the virus? Nope, we are not injecting people with bacteria. Immune cells. We are not injecting people with immune cells in most common vaccines. Pieces of the virus, yes, maybe. And a lot of different microbes. Nope, no bacteria, no little things other than pieces of the virus. Your answer is C. And last one, why do viruses need to enter a host cell? Because they need to reproduce. They need to reproduce. They cannot do this by themselves. They need a little machine that makes more viruses because they cannot do it by themselves. That's why they need a host cell.